Hello students, I am Dilipudani, Assistant Professor at LJ Institute of Engineering and Technology. In application of partial derivatives, today I will teach you gradient and directional derivative. So first of all, what is gradient and directional derivative? Gradient means vector which is normal to a given surface, and directional derivative means the derivative in a given direction, or it is defined as the dot product of gradient and a unit vector in a given direction. So let's start. So first of all, what is gradient? The gradient of a function z equals to function of xy is written as grad f and is defined as grad f that is equals to nebula f. This symbol is nebula. That is equals to I del f by del x plus j del f by del y plus k del f by del z. This is how we define grad for the given function f. Grad f is a vector function, as you can see. This is a vector physical quantity. A gradient of a function represents a normal vector to the surface function of x, y, z equals to c. The directional derivative of a function f of x, y, z in the direction vector a bar is given by daf, that is equals to nebula f dot a cap. Nebula f, that will be as it is, and a cap is a unit vector. So how we will define a unit vector? That is a vector divided by its magnitude. So this is how we define directional derivative for function of f x y z in the direction of vector a bar. Now we will see examples related to this topic. Example number 1 is, if phi equals to 3x square y minus y cube z square, then find grade phi at the point 1 minus 2 minus 1. So grade phi, that is equals to nebula phi I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. This is how we define grade phi or nebula phi. So first of all, we will find out del f by del x, then after del f by del y, and then after del f by del z. And then after we will replace x by 1, y by minus 2 and z by minus 1. So I cap will be as it is. Now we have to find out partial derivative of phi with respect to x. So we will keep y and z constant. So derivative of x square is 2x. 2x into 3 into y, that is 6xy, because y is also constant. Then after y cube z square is constant, so definitely its derivative will be 0. Then after we have j cap. Now del phi by del y. Del phi by del y, it means partial derivative of phi with respect to y. So we have to keep x and z constant. So 3x square will be as it is, and derivative of y with respect to y, answer is 1. Then after this minus sign will be as it is, z square is constant, so it will be as it is, and derivative of y cube, that is 3y square. Then after plus k cap will be as it is. Now we have to find out del phi by del z, and del phi by del z means partial derivative of phi with respect to z. So we have to keep x and y constant. So for this term 3x square y, the derivative will be 0 because it is a term containing x and y. Then after minus sign, now derivative of z square will be 2z and y cube is constant. So this is grade phi, but we have to find out grade phi at point 1, minus 2 and minus 1. So in this function we will replace x by 1, y by minus 2 and z by minus 1. So at point 1 comma minus 2 comma minus 1, grade phi that is equals to nebula phi equals to I cap. 6 will be as it is, replacing x by 1 and y by minus 2 and simplifying the result, that will be minus 12. Then after plus j cap will be as it is, 3 multiplied by the value of x is 1, so 1 square is 1, 1 into 3 answer is 3. And after minus 3 replacing y by 2, 2 square is 4, replacing z by minus 1 square is 1, 1 into 4 into 3 that is 12. Then after plus k cap, then after minus 2, y is minus 2 raised to 3 that will be minus 8 into minus 2 that will be plus 16, and then after replacing z by minus 1 so it will become minus 16. So nebula phi or grade phi that is minus 12i, 3 minus 12 is minus 9j, then after plus minus 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 16k. So this is grade phi for the given function at the point 1 minus 2 minus 1. Now we will see example number 2 related to this topic, that is if phi equals to logarithm of x square plus y square plus z square, then we have to find out grade phi at the point 1 0 minus 2. So grade phi that is equals to nebula phi and that is equals to I del phi by del x plus j del phi by del y plus k del phi by del z. So first of all we will find out del phi by del x, then after del phi by del y and finally del phi by del z. So I cap that will be as it is. Now del phi by del x, that is partial derivative of phi with respect to x. So we will keep y and z constant. And as you know that the derivative of log x is answer is 1 upon x. So we have 1 over x square plus y square plus z square. But in place of x we have x square plus y square plus z square. So we will differentiate x square plus y square plus z square partially with respect to x. So derivative of x square is 2x. Then after derivative of y square and z square will be 0. Then after plus j cap will be as it is. Now del phi by del y, that is partial derivative of phi with respect to y. So we will keep x and z constant and derivative of log x is 1 upon x. But in place of x we have x square plus y square plus z square. So it is 1 over x square plus y square plus z square. So again we will differentiate x square plus y square plus z square partially with respect to y. So x square and z square will be constant and its derivative will be 0 and derivative of y square is 2y. Then after plus k cap del phi by del z, that is partial derivative of phi with respect to z. So derivative of log x is 1 over x. So that will be 1 over x square plus y square plus z square. And in place of x we have x square plus y square plus z square. So again we will differentiate it partially with respect to z and derivative of x square and y square will be 0. Now derivative of z square is 2z. But we have to find out nebula phi or del phi at point 1 0 minus 2. So in this function we will replace x by 1, y by 0 and z by minus 2. So at point 1 0 minus 2, grade phi that is equals to nebula phi equals to I, replacing x by 1. So 2 into 1 it is 2 divided by 1 square is 1, 0 square is 0, minus 2 square is 4. Then after j cap, and if you will replace y by 0, so this whole term will become 0. Then after plus k cap, replacing z by minus 2. So 2 into minus 2 that is minus 4 and divide by 1 square is 1, 0 square is 0 and minus 2 square is 4. Now we have to simplify this result. So this is 2 by 1 plus 4 5. So 2 by 5 I cap. This is 0. So no need to write down this term. Then after this is minus 4 by 5 k cap. So 2 by 5 I minus 4 by 5 k cap. This is the required gradient of given function phi at point 1 0 minus 2. Now we will see example 3 related to this topic, that is find a unit vector normal to this surface, that is x cube plus y cube plus 3xyz equals to 3 at the point 1 2 minus 1. So a normal vector to a given surface, that is nothing but the gradient. So first of all, we will find out the gradient for the given surface. Then after we will find out its unit vector. Okay, here phi is x cube plus y cube plus 3xyz minus 3. So grade phi, that is equals to nebula phi, that is equals to I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Now we will find out del phi by del x first. I cap will be as it is. Del phi by del x means partial derivative of phi with respect to x. So we will keep y and z constant. Derivative of x cube, that is 3x square. Derivative of y cube is 0 because it is constant. Then after plus dyz will be as it is, and derivative of x is 1. So the result is dyz. Then after plus j cap will be as it is. Now del phi by del y. So that is partial derivative of phi with respect to y. So x cube is constant, its derivative will be 0. Then after derivative of y cube is 3y square. Then after 3xz will be as it is, and derivative of y with respect to y, answer is 1. So 3xz into 1, the result is 3xz. Then after minus 3 is a constant value and its derivative will be 0. Then after plus k cap, and now del phi by del z, that is partial derivative of phi with respect to z. So we will keep x and y constant. So derivative of x cube is 0, y cube is 0, and for this term 3xyz, 3xy will be as it is, and derivative of z with respect to z, that is 1. So 3xy into 1, that is 3xy, and minus 3 is a constant value, so its derivative will be 0. Now we will find out nebula phi at point 1, 2, minus 1. So in this function we will replace x by 1, y by 2 and z by minus 1. So this is I cap replacing x by 1, so it is 1 square into 3, that is 3. Then after y is 2 and z is minus 1, so 3 into 2 into minus 1, that is minus 6. Then after plus j cap, y is 2, 2 square is 4, 4 into 3 is 12. Then after x is 1 and z is minus 1, so 3 into 1 into minus 1, that is minus 3. Then after plus k cap, 3 will be as it is, x is 1 and y is 2, so 3 into 1 into 2, that is 6. Now we will simplify this function. So 3 minus 6 is minus 3, so it is minus 3i. 12 minus 3 is 9j, and after 6k. So this is grade phi, or this is a normal vector to a given surface, that is this one. Now we have to find out a unit normal vector. So we will find out the unit vector for this nebula phi. Now unit normal vector, that is nebula phi over magnitude of nebula phi. This is how we define unit vector. So nebula phi, that will be as it is, minus 3i plus 9j plus 6k, and divided by, how to find magnitude of nebula phi, that is square root of its x component square plus its y component square plus this z component square. So minus 3i plus 9j plus 6k, that will be as it is, and divided by minus 3 square is 9, 9 square is 81, and 6 square is 36. So adding all the three terms, we have square root of 126. So this is the required unit normal vector to a given surface at point 1, 2, minus 1. Okay, now we will see example number 4. The temperature at any point in a space is given by T equals to xy plus yz plus zx. Determine the direction derivative of T in the direction of the vector a bar equals to 3i minus 4k at the point 1, 1, 1. Now in this example, we have to find out the directional derivative. So to find out directional derivative, first of all we will find out grade of a given function, that is xy plus yz plus zx. Then after we will find out the dot product of grade phi and a unit vector, that is 3i minus 4k. So grade T, that is equals to nebula T, that is equals to I cap del T by del x plus j cap del T by del y plus k cap del T by del z. Now first of all we will find out del t by del x. I cap will be as it is. Del t by del x means partial derivative of t with respect to x. So we have to keep y and z constant. Y will be as it is and derivative of x is 1, so it is y. Then after derivative of yz will be 0. Now for this term, that is zx, derivative of x is 1 and that is constant, so 1 into z, that is z. So we have del t by del x, that is y plus z. Similarly we will find out del t by del y. J cap will be as it is. Del t by del y, it means partial derivative of t with respect to y, so we have to keep x and z constant. So for the first term xy, x is constant, derivative of y is 1, so it is x. Then after for the term yz, derivative of y is 1 and z is constant, so it will be z, and zx is constant, so its derivative will be 0. Now plus k cap del t by del z, that is partial derivative of t with respect to z, so we will keep x and y constant and derivative of xy will be 0 because it is constant. And for this term yz, y will be as it is and derivative of z is 1, so 1 into y, it is 1. Then after plus derivative of z is 1 and 1 into x, the result is x. Now we will find out grade t at the point 1 1 1. So in this function we will replace x by 1, y by 1 and z by 1. So it will become grade t equals to nebula t equals to 1 plus 1 is 2, so it is 2y. Similarly it is plus 2j plus 2k. Now, directional derivative. In the direction of the vector a bar equals to 3i minus 4k at the point 1 1 1 is given by. This is how we define direction derivative. DAT, that is equals to nebula t dot a cap. Nebula t will be as it is and a cap is a unit vector in the direction of a vector. So that will be a vector divided by its magnitude. Now nebula t, that is 2i plus 2j plus 2k. Then after a bar, that is 3i minus 4k and divided by magnitude of a bar, so it will be square root of its x component square and x component is 3, so 3 square is 9. Then after plus its y component square and that is minus 4, so minus 4 square is 16. Now we will simplify this result. So 2 into 3, it will be 6. Here we have the term of j, but here the term of j is absent. So considering that particular term as 0, so 2 into 0, it will become 0. And then after 2 into minus 4, so it is minus 8 and divided by square root of 25 and that is 5. So 6 minus 8, that is minus 2 by 1. So this is the answer, or you can say this is the direction derivative of the given surface in the direction of this vector at point 1 1 1. Now we will see example number 5, that is find the direction derivative of the surface phi equals to x square minus y square plus 2z square at the point p 1 2 3 in the direction of the line PQ, where Q is the point phi 0 2. So here the surface phi is x square minus y square plus 2z square. So first of all we will find out grade phi. So grade phi, that is equals to nebula phi and that is equals to I del phi by del x plus j del phi by del y plus k del phi by del z. So first of all we will find out del phi by del x, that is partial derivative of phi with respect to x, so we will keep y and z constant. So derivative of x square is 2x and derivative of minus y square and plus 2z square, that will be 0 because these terms are constant. Then after plus j will be as it is. Now del phi by del y, that is partial derivative of phi with respect to y, so definitely we will keep x and z constant, and derivative of x square and 2z square, that will be 0, and derivative of minus y square, that is minus 2y. And then after plus k cap will be as it is. And now we will find out del phi by del z, that is partial derivative of phi with respect to z, so we will keep x square and y square constant, so its derivative will be 0. and derivative of z square is 2z. So 2z into 2, that is 4z. Now we will find out nebula phi at point 1, 2, 3. So replacing x by 1, y by 2 and z by 3 in this function. So we have grade phi equals to nebula phi equals to 2 into 1, that is 2, I cap will be as it is, plus j cap will be as it is, replacing y by 2, so it will become minus 2 into 2, so that is minus 4, plus k cap, and replacing z by 3, so we have 4 into 3, that is 12. So grade phi at the point 1, 2, 3, that is 2i minus 4j plus 12k. Now we have to find out direction PQ. So direction PQ, that is 504. This is the position vector of point Q. Then after minus, this is the position vector of point P, that is 1, 2, 3. So this is the required direction. 5 minus 1 is 4. Then after 0 minus 2, that is minus 2. And 4 minus 3, that is 1. So this is the required direction. And this is equals to 4i minus 2j plus 1k. Now direction derivative in the direction of the vector a bar, that is equals to 4i minus 2j plus k cap at the point 1, 2, 3 is given by, that is direction derivative of surface phi at the point A, that is equals to nebula phi dot a cap, where a cap is a unit vector, so nebula phi will be as it is, dot, and a cap is a vector A divided by its magnitude. So nebula phi, that is 2i minus 4j plus 12k, and a bar is 4i minus 2j plus k cap divided by its modulus, and that is square root of its x component square, that is 4 square, and that is 16, plus y component square, that is minus 2 square, and that is 4, plus z component is 1 and its square is 1. Now we will simplify this result. So you can see that 2 into 4, that is 8, then after minus 4 into minus 2, that is again plus 8, and finally plus 12 into 1, that is 12. Now you will now adding 16 plus 4 plus 1, so that is 21, so it is the square root of 21. Now we will simplify this result, that is 8 plus 8, that is 16, and 16 plus 12, that is 28. So the direction derivative of the given surface phi in the direction of the PQ vector, that is 28 divided by square root of 21. So in this lecture we have discussed what is gradient and direction derivative, and then after 3 examples related to gradient and 2 examples related to directional derivative. Thank you for watching this video. I will see you in the next lecture.